Okay, and this is just the formal definition of what we said in the last two videos. A local max is just there is some interval around you. An interval goes both left and right so that that point is the highest or the lowest point. So this guy would be a local max because in this interval, say right there, in that interval I from here to here, that's the highest point. That's the global max of that interval. And that interval could be as small as it needs to be, as long as you're the highest point, you're the top of a hill, and you're higher than all the points to the left of you and to the right of you, you're a local max. Same thing there. That guy's higher than all of these points over here, and he's higher than all of these points over here. This could be my interval here. Hi, that interval right there. He's the highest point there. And then this guy, I could take this interval here. He's the highest point in this region, or the lowest point in that region. This would be a local min, and these would both be local maxes. That guy there would also be the global max because he's the highest point overall. And if these go on forever, this guy would have no global min. This is global or absolute min. There's no lowest value. You can have locals without having globals. If this function were defined on a bounded closed interval, the extreme value theorem would say it has to have a global min. But it's not. It's defined on an unbounded interval. So we're not guaranteed to have any globals. It happens to have a global max, but it didn't have to if it's bounded or defined on an unbounded interval. Okay, so we've got ourselves some function with some domain. Interior points are points that are not endpoints of our intervals. We call any place where the derivative equals 0 or is undefined. Don't forget that. That's the one people forget. Critical points are x values. That's x equals c right there. Critical points are x values where the derivative either equals 0 or is undefined. How can your derivative be undefined? If you have a sharp corner. Fermat's theorem here says that local maxes and mins occur at critical points. So if we've got ourselves some function and we want to find our maxes and mins, if we want to maximize profit or minimize cost, we set the derivative equal to 0. We figure out any place where the derivative doesn't exist. We find our critical points. And we know all local maxes and mins will occur at critical points. Global maxes and mins can also occur at endpoints. So we check all our critical points, we check all our endpoints. So in all of these places, derivative equals 0 whenever your tangent line is horizontal. We already knew that. Derivatives undefined wherever you have a sharp corner. So like right there on some kind of absolute value, we might have a sharp corner. The derivative's undefined there. Sometimes we have the derivative equal 0 and we get what's called a saddle point. It's neither a max nor a min. Y equals x cubed looks like this, and his derivative at 0 is neither going to be a max or a min, but it's still a critical point. Sometimes we have a derivative that's undefined because we get an infinite tangent line. Our tangent line is vertical. And in this case, that would not be a local max or min. It goes the other way. This is not if and only if. See, this theorem doesn't say you have local extrema at every critical point. It says all your local extrema occur at critical points. We'll do a bunch of examples in the next video.